Okay. So a pregnancy test is designed so that it will correctly detect a pregnancy 99% of the time and correctly determine that a person isn't pregnant 90% of the time. So if the null hypothesis is not pregnant, describe both type of errors and find their probabilities. All right, so the null hypothesis would be not pregnant, and the alternative hypothesis would be pregnant. So, and it tells us here to use the null hypothesis is not pregnant. Describe both types of errors and find their probabilities. So, null is not pregnant, the alternative is pregnant. So, type 1 error, reject the null. So, what did we decide? Okay, if you reject the not pregnant, you're saying that you're pregnant. I decide, or we could just make it simple. You can say you're pregnant, but what? You're not. So if you reject this, but it's actually true, you reject it, you say you're pregnant, but you're actually not. So you say you're pregnant when you're not. Okay, and what's a type 2 error here?
You say you're not pregnant when reality you are.
Very good. Say you are not pregnant in reality you are. So, both of these errors are bad decisions, okay? They're mistakes. Their probabilities aren't really very high because they're also good decisions you can make. So when you do a hypothesis test, a good decision is deciding you're not pregnant when you're not pregnant. Isn't that a good decision? Okay? So the probability of making a type 1 error, of deciding you are pregnant but you're not, is alpha. So alpha, what is the alpha level in this problem? Okay, the error is deciding you are pregnant, but you're not pregnant. So we have to decide what is the alpha level here. What was the 0.01? So it correctly detects a pregnancy 99% of the time. So 99% of the time it'll say a person is pregnant when they are, and 1% of the time it will say a person is not pregnant when they are pregnant. So which of those does that go with? It goes with the type 2. So this the 99% is the good decision. The extra, the other, the 0.01 is actually the type 2 error. Okay, this is actually called beta. The probability of a type 2 error is denoted by beta. Okay, beta is the probability of a type 2 error. Okay, so now it says it correctly determines that a person isn't pregnant 90% of the time. So that decision, saying they're pregnant, they're not pregnant when they're not pregnant, is 90%. But the other, saying they're not pregnant when they are, or no, saying they're pregnant when they're not, would be the type 1 error. And if it does the right decision 90% of the time, 10% of the time it makes the wrong decision. So alpha goes with the 10% here. Now, most of the time you're not asked to find the probability of a type 2 error. You're not asked to find beta, ever, in AP stats. Okay, if you take other stats beyond this class, in college you might find beta, but not now. You'll be asked to choose alpha. You need to realize that alpha is the probability of making a type 1 error, rejecting the null when it's true. All right, so which of these do you think is a worse scenario? Which of these is a worse scenario? Saying you're pregnant when you're not, or saying you're not pregnant when you are? Why is type 2 worse in this situation? Yeah. If you say you're not pregnant but you really are you gonna, I mean,
You're not going to take the proper precautions.
yeah, you're not gonna take care, you're probably not gonna you're not going to the doctor, you may not change your diet, certain things that you drink or do that could be unhealthy to the baby. So if you think you're not pregnant but you really are, there could be some issues, health issues for you and the baby, okay? Yeah, exactly. Yeah. Now, emotionally, would a type 1 error be still a big deal? You think you're pregnant when you're not pregnant. I mean, and some of you are thinking, well, what if you really wanted to be pregnant, and you can't have kids, and so you think you're pregnant, but you're not. I mean, that's a bad deal too. Yeah, it's a bad deal. But as far as, health situation, that might be the worst of the two. And sometimes it's a matter of opinion, deciding which type is worse. So I want to go back up and look at this innocent guilty thing. So in a trial, there's 2 errors. Okay, so what do you think is worse in the trial situation, convicting an innocent person or letting a guilty person go free? Yeah, convicting an innocent person. I mean, there's guilty people walking around all the time. I mean, people do crimes all the time and don't get caught and are nothing's perfect or, in the world, but I think it's worse to convict an innocent person. I agree. I don't want someone who didn't do the crime. And plus, someone in last period brought up a good point. It costs the government a lot more money when we're, So, I don't know. All right, so next page. When we're conducting a hypothesis test, we choose the significance level alpha. So you get to pick that. So in other words, you pick the probability of a type 1 error. So you really don't have a lot of control over beta. And the common choices for alpha are 10%, 5%, 1%. So, sometimes in the case of, well, we'll talk about that down here, so we don't need to worry about it now. So why don't we make just alpha very small to minimize the probability of a type 1 error? Why don't we just say, well, we always want a type 1 error to be really small, so we'll just always pick 0.01. And some of you have defaulted to 0.01 because I said you can pick it. Well, sometimes that's not the best idea. I think maybe if you're going to pick a default, 1.05 might be better because it's somewhere in the middle. Because the different scenarios, the judicial system and the pregnancy test down at the bottom will talk about, it's better to have a high or low alpha level sometimes. So here's, you can't just always make alpha really low to minimize a type 1 error because sometimes a type 2 error is worse. But what you need to realize is that alpha and beta have an inverse relationship. Alpha and beta have an inverse relationship. Meaning if alpha goes up, beta goes down. And vice versa. So alpha and beta have an inverse relationship. If alpha goes down, or if alpha goes up, beta goes down. If alpha goes down, beta goes up. So the lower you make alpha, the higher beta becomes. So if you make alpha go up, then the probability of a type 1 error goes up, the probability of a type 2 error goes down. So they have an inverse relationship. So we'll talk more about this relationship in the next set of notes when we start talking about power and all the decisions that can be made. So if we just look down at the bottom, to choose an appropriate value for alpha, consider the consequences of making each type of error, okay, and choose the largest alpha value that is tolerable between 0.01 and 0.02. Okay, so you should always consider consequences of making each type of error. So for the farmer, the farmer had the tomatoes, he wanted to test the fertilizer. The type 1 error was deciding the fertilizer worked when it didn't and wasting money. And the other one is deciding that the fertilizer didn't work, but it did, and not, missing an opportunity to make more money. In that situation, it's really, it's totally up in the air. What's worse, a type 1 or type 2? You're losing money, or you're wasting money, or losing a possible earning. So they're both kind of bad. So in that situation, I'd pick like a 0.05. Okay? In the judicial system, alpha should be low because we'd rather let a guilty person go free than convict an innocent person. So this is ensured with the requirement that the evidence be beyond a reasonable doubt in order to say that they're guilty. So in other words, alpha needs to be really low. We don't want to make a type 1 error. So we want the probability of that type 1 error to be super small. So like maybe 0.0001, who knows? You could make it really tiny. And that's why they look for consensus among all the jurors. Everybody has to have the same thought, especially in high stakes cases. Okay, in the pregnancy test, it's worse to think you're not pregnant and be pregnant. And that's the type 2 error. So you want beta to be low in that case. So basically then you'd pick a high level for alpha. So like in the judicial system, you'd pick alpha equals 0.01 because you want the type 1 error to be low. If you want the type 2 error to be low, then you pick the highest alpha you can pick. Because you don't pick beta. Beta's not something you have any control over, really. And we'll talk about that the next time. So, other considerations for choosing alpha: extraordinary claims require extraordinary evidence. Smaller values of alpha should be used to test claims that don't have much other supporting evidence. So, if there's really not much evidence out there, there's no other studies or anything, you're the first one who's asked this question, done this survey, then you would pick a very small alpha level. Okay, so on your homework, there's a mistake here. This last problem on page 491 should not be problem 11, it should be problem 19. And I think the pages are a little different. Like I think this is actually starts on page 499. It's after chapter 21 here. So this is actually page 499. Not page 491, and that's in problem 19, A through D. And then the other page, I believe, is correct. No. It's not 471. It's 477 and 76. Starts on 477 here, so.